will not make too much of a difference if the program would have been, say, 1 into 2 square. Now, how is square written? Square is generally written like, you can say 2 square is 2 into 2, but square is explained like this, is written like this. This means 2 square. So, I mean that if I write 5, this is 5 square. If I write this is 7 square. So, I think you understand. So, will not make too much of a difference if the program would have been 1 into 2 square plus 2 into 3 square plus 4, sorry, if not 4, 3 into 5 square. In fact, this actually means to the power of. So, though I have explained it in terms of square, but actually 7, then this symbol, then 3 would have been 7 cube. Anyway, that does not make a difference over here, but it means 3 into 5 square, then plus, what will be the next term? 4 into then 7 square, isn't it so? Then 5 into 9 square. So, I think you understand this. What have I done? This is increasing by 1 by 1. The first term 1, then 2, then 3, then 4. This is increasing 1 by 1, then 5 and so on. However, the second part is increasing 2 by 2. That is 2, firstly 2 followed by 3. No, it is not 3. I am absolutely wrong. This would have been 1 square, not 1 into square. I am extremely sorry. So, it is 1 into 1 square plus 2 into 3 square. So, this is increasing 2 by 2, 1 square, then 3 square, then 5 square, then 7 square, then 9 square and so on. So, this is how it is increasing. And the last term, what is the last term? The last term would have been, if it continues up to n, then this is n. So, what is the second part? N into, please understand, this is 1. What I have done is, this is 1. This also started from 1. This also started from 1. So, this is 1. But this has increased by 1 each. This has increased by 2 every time. This is 3. So, 1, 2, 3, 4 and so on. However, the second part has increased by 1, 3, 5, 7 and so on, 9 and so on. So, if you really look into it, see, this is again 2n minus 1. 1, 2 into 1 minus 1 is 1. This is 2, then 2 into 2 minus 1 is 3. Then this is 3, 2 into 3 minus 1 is 5. This is 4, so 2 into 4 minus 1 is 7. This is 5, 2 into 5 minus 1 is 9 and so on. So, definitely the last one will be n into 2n minus 1. So, let me write it as 2 into n. 2 into n minus 1, that is 2n minus 1 whole square. So, I think you understand this. This is what the program expects. So, I want to write this program, hardly any difference from the previous program. Actually, it is the same program, only thing is the square part is added to it. So, it hardly matters. Let me quickly write this program and go to the next program, because this is hardly anything. So, main. So, I will have to take two variables I and j. Why am I taking two variables? I will be taking this as I and this as j. I will take this as I, this as j. This is I, this is j. This is I, this is j, which means I is increasing by 1 and j is increasing by 2. So, int I j, and obviously I will need a sum variable to hold the entire sum, and the n up to which I would like to add. This n will definitely be inputted by the user. So, let me start very quickly. Printf enter the value of n. So, this I ask from, this I ask from the user. So, this I ask from the user. This is wrong. So, this is what I ask from the user. Enter the value of n. Then I will scan it, scanf, scanf %d ampersand n. So I scan the value within n variable. So definitely I will need a sum variable to be initialized to 0, because initially this whole thing sum, this whole addition is sum, which is 0 initially. Then gradually this will be getting added to it one by one. So sum is 0. Obviously I, that is the first part of the term, must be 1, and j should also be equal to 1. Check out what this is. I, this is I, this is j, this is I, this is j. So both I and j have started from 1. However, every time in the loop I will be increasing by 1 and j will be increasing by 2, almost the same program. So I equal to 1, j equal to 1. I could have written these two things just to learn a new thing. See, I could have written these two things as I equal to j equal to 1. Please understand, I equal to j equal to 1 would have meant that j is 1, I is also 1. How come? See how come. In equal to, what happens? It is an assignment operator. The right side gets assigned to the left side. So firstly this 1 would have been assigned to j. So the value of j will be 1. Then again this j will be assigned to I. So value of I will be equal to 1. This assignment operator starts from right and goes up to left. I explain again. This 1 will be assigned to j first. Then j becomes 1. Then this value of j1 will be assigned to I. So I equal to j equal to 1. It will mean I equal to 1, j equal to 1. Just a new thing. So while, how long will I continue? See, this I will start from 1, then become 2, then become 3, then become 4, then become 5, and so on. So it is increasing by 1. How long? It will go up to n, but cannot be n plus 1. So definitely while I less than equal to n. So what is sum? Sum equal to, this is wrong, sum equal to sum plus, check out what, this is I, so sum plus, this is I, this is j, so sum plus j square, is not it so? So it is sum plus j into j, because j square cannot be done. This is not an operator actually. This is just to explain. This explains that it is square. It explains the power sign, but we cannot do it like this. J into j. J square means j into j. So sum plus, not j into j only, I into j into j. Sorry, I into j into j. Why? Check out why. This is I, this is j. So I into j square. So I into j into j. I will only need I to be incremented by 1, I equal to I plus 1, and j equal to j plus 2. If you remember, I could have written I equal to I plus 1. Instead of that, I could have written I plus equal to 1. Do you remember? I equal to I plus 1 can be written as I plus equal to 1, and j equal to j plus 2 can be written as j plus equal to 2. However, plus equal to 1 can also be written as I plus plus. So I plus plus means I equal to I plus 1, j plus equal to 2 means j equal to j plus 2. So this is done, and this will be the output. So very simple, printf the sum is %d. What is that? Sum. The variable sum contains the final sum. So you end it, don't forget the get ch at the end, and don't forget the clear screen at the front. I want a clear screen before I start. So clear screen at the front. So let me run this program again. I believe I have written, no, I have not written, hash include stdio.h and hash include conio.h. I have made a mistake, na? Yeah, stdio.h, hash include conio.h. So let me quickly run this program, and it will give you the output. Alt enter. So if I take 3, that means 1 into 1 square, which is 1, plus 2 into 3 square, that is 2 into 9, 18. 1 plus 18 is 19, plus 3 into 5 square. So 5 square is 25, 3 into 25 is 75. 75 plus 19 is 94. So the sum is 94. I think you understand this very clearly. If I run it again and this time I give 4, it will be 94 plus the last term will be 4 into 7 square. 7 square is 49. 49 into 4 is 196. 196 plus 94 makes it 290. Yeah, so that is the sum. So this is absolutely working. I think you have understood this. If I slightly continue with this and ask you, if I change this program a little bit and make it 1 into 2 square plus 2 into 4 square followed by 3 into 6 square. Can you guess what is this? 4 into 8 square plus 5 into 10 square and so on. What is this? N into what? What did I mean? You check out what I am saying. 1 into 2 square plus 2 into 4 square plus 3 into 6 square plus 4 into 8 square. So this is very simple. If this is 1, this is 2. If this is 2, this is 4, this is 3, so this is 6, this is 4, this is 8, this is 5, this is 10. So it's definitely n into 2n square, n into 2 into n whole square. So is not so? How can I write it? It is very easy. You check out what over here. If you think this is I, and this is j, then this is I, this is j, this is I, this is j. So this time I has started from 1, j has started from 2. So you remember this is I equal to j equal to 1 previously, but this time I will start from 1, but j does not start from 1, j starts from 2. You see this? I is 1, j is 2, I is 2, j is 4. So I starts from 1, j starts from 2. So while I less than equal to 1, this is sum equal to sum plus I into j is still true, because sum equal to sum plus I into j, I into j, because this is square. So this is fine. But over here j has started from 2. So I plus plus and j plus equal to 2 is absolutely correct, still correct. I is plus plus, I is incrementing by 1. But see, j is incrementing by how much? 2, then 4, then 6, then 8. So j is incrementing by 2, and I will continue as long as I is less than equal to n. It hardly matters, it is almost the same program. So I can again run it and check out. Alter, enter the value of n. Let me take 3. So it means 1 into 2 square, that is 1 into 4. 2 square is 4, 1 into 4 is 4, plus 2 into 3 square, 3 square is 9. So 2 into 4 square, sorry, 2 into 4 square. So 4 square is 16, 2 into 16 is 32. So it was 4 plus 32 plus 3 into 6 square, 4 plus 32 is 36. Then 3 into 6 square, 6 square is 36, 3 into 36 is 108, 108 plus 36 is 144. So the sum is 144. So this will work absolutely fine, hardly matters, almost the same program. You can take a bit of rest, however I am continuing with it. You can pause my video and definitely you can come back again, but still I continue with this, asking you, say this is 1 into 2 square, if 1 into 2 square, 2 into 4 square. Achha, what if this is 1 into 1 square, this is 2 into 4 square, this is 3 into 9 square, this is 4 into, what do I mean, 16 square, this is 5 into 25 square. So can you guess what is this one? It is 6 into 36 square. Why am I doing like this? See what? 1 square is 1, so this is 1, this is 1. 2 square is 4, so this is 2, this is 4. 3 square is 9, so this is 3, this is 9. 4 square is 16, so this is 4, this is 16. 5 square is 25, so 5 and 25. 6 square is 36, so 6 and 36. So this can be done very easily. You know, over here, this is I, this is j. So j is equal to what? I into I. So j is nothing but I into I. and j does not have a straightforward relation if I compare it with the previous term. It is not a straightforward relation. So I can say always j is related to I in the sense that j is I square. So it is basically 5 into 25 square. What does it mean? It means 5 cube. 4 into 16 square. What does it mean? It means 4 cube. 3 into 9 square. What does it mean? 3 into 9 square is 3 cube. So over here, if you really look at it, there are not two i's, I and j's. There is a single I. This is 3 cube. This is 4 cube. This is 5 cube. This is 6 cube, and so on. So cannot I do it only with the help of I? I can be equal to 1. I can simply get rid of j over here. I can simply get rid of j over here. And I can start from 1. See over here, I is starting from 1, then 2, then 3, and so on. So this is sum equal to sum plus what? I cube. I cube can be written as sum plus I into I into I. Is not it so? And I plus plus is absolutely fine. J is absolutely not needed. I can get rid of this and I can run this program. This will run absolutely fine. Fine if I really want 1 cube plus 2 cube plus 3 cube and so on. Alt enter. So if I write 3 this time, 1 cube is 1, 2 cube is 8, 3 cube is 27. So 27 plus 8 is 35 plus 1 is 36. The sum is 36. This will work absolutely fine, and I will stop over here and you take a bit of break and you can come back. Thank you.